Okay, welcome to Chapter 6 VLANs. Okay, so in this one we're going to learn about VLAN segmentation, VLAN implementation, and inter-VLAN routing using routers. What VLANs are basically virtual networks that you can create within a switch, so you don't have to go out and buy multiple switches. You can do the same thing within the environment that you're in. Okay, so as you can tell from this graphic here, on one switch you can have a VLAN that is IT, a VLAN that is HR, and sales. Each one of these is completely separate from the other, so when it comes to protection or security, you know that this VLAN will not interfere with this one or this one unless you wanted to. VLANs allow like administrators to focus on team projects. It involves layer 2 devices, and remember, like I mentioned before, every VLAN is a separate network of its own. So if you have a 24-port hub, you can have multiple VLANs and they will not see each other unless you want them to. Here's an example of a VLAN. We have VLAN 10, which is going to be faculty only, VLAN 20, students only, and 30, guests only. So like here at Doyle Community College, we could have a VLAN for faculty where we only see the resources of that. Students would have their own connection, and then anybody coming in visiting can connect with guests, but would only have access to whatever is shown on their particular VLAN. When you collect VLANs, you have different types of VLANs. You have a data VLAN, which generates traffic. You have a default VLAN, which is the one that you would normally have, which is the whole switch by itself. You have a native VLAN for untagged traffic, and you have the managed VLAN. The managed VLAN here is important because this is how you program your switch to actually become VLANs. Here, when you do a show VLAN brief, you see the VLAN active, and here's our reports: fast Ethernets and gigabit ports. Typically, the FDDI would be fiber optic, token, so forth as you go down the list there. The voice of VLANs are basically, you can actually determine that this area here is a totally separate VLAN from anybody else. So you can assign it to be voice, you can assign it to be student, you can assign it to be faculty, whatever you wish to be. So that's something that you need to pay attention to when you program your VLANs. What do you want to call them? VoIP, or voice over IP, is replacing your old analog phone. It doesn't take up as much bandwidth as normal devices, but you do have a replacement of phone. The problem that I have with VoIP is, in the old days, when you would lose your internet, your analog phone would still work, so you could still call out and see what's going on. When your internet goes down with a VoIP type situation, you lose everything, phone and voice. So just be aware that have an alternative to get out in case you need to, because it will, restrict your capability of calling for help or whatever the case may be. Trunking is a very interesting term. Trunking basically means that you can take VLAN 10, VLAN 20, VLAN 30, and you can run them through one cable, and then it will reassemble itself on the side. Trunking came from the old POTS term, plain old telephone system, which means in the old days, if you had a phone call, like here for instance, all three of these would be three separate connections. So what a trunk does, it allows the information from the three connections to go through one cable, part VLAN 1, or part VLAN 10, part VLAN 20, part VLAN 30, and then over here it reassembles it to its thing. It just saves cabling and time and effort on that. A VLAN trunk is a point-to-point link, which means that it connects physically point to point to where you're going to where you're ending up. Trunking, without trunking, we would have phone cables, internet cables all over the place. Trunking just allows one cable to handle multiple connections, multiple data paths at one time. It like shares it. You go here, 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 you go here. And then at the other side, it puts it back together in a cohesion method. Controlling broadcast domains, what this does is this allows you, even though a switch does not create a broadcast domain, because you're using VLANs, VLANs are broadcast domains, broadcast domain, broadcast domain. So if you don't have a VLAN, everybody sees everybody else. If you create a VLAN, it now separates it between faculty, student, and guest. It's just another way of making, or actually managing your computer network without having to buy more equipment or update. When you segment one, now you have, okay, we have faculty here, faculty, and student here. So what this basically means is traffic coming from faculty will just go to faculty. Traffic from student will only go through student. VLANs are important because they are like many broadcast domains. They can break down your traffic after the broadcast domain or your router has done that, which means you can make smaller networks within VLANs that broadcast domains typically do, but they are larger versions of the same thing. Frame tagging, like I said, it's the whole idea of telling where you're going on a VLAN. What VLAN are you on? What information do you have? What packets do you have? And what security type do you have? So frames are very important when it comes to that aspect of it. This right here is just an example of how it is tagged. You've seen this many times. All this is for your reference, so kind of just pay attention to tagging. Okay, now we have VLAN and 802.1q tagging. This is basically what type of security methods, path, protocol you're using when it comes to your VLAN. Voice VLAN tagging is a little different, but it's still the same kind of thing. It will tell you what type it is and what it is when it comes to voice VLAN. All you have to remember is on voice, it is like your old analog RJ11 connection. It was analog to analog. Now it's analog, digital, analog, or digital, digital. It's just another way of getting the same information from point A to point B. Okay, now we're going here to predictive switch. So now it's going to say, okay, this VLAN here will only talk to this one here to this one. So it's not knowing what's going on. You can predict the traffic and where it's going on a given VLAN. Okay, VLAN implementation. We have various routers, 2960, 3560, but depending on the organization will determine the amount. You can typically have 1 to 1,005 VLANs. If you have that many VLANs, I highly suggest that you get more switches. The more VLANs you have on a switch, the harder it is to manage a switch, therefore more complex. And all of the information is stored in what's called a VLAN.dat file or data file. And it is stored in the flash memory. So just be aware of that when you do that. If you want to show your regular VLAN outlook or view, just do a show VLAN brief. And as you can see here, the default has all of your current ports and gigabits on the one VLAN. Creating a VLAN is quite simple. All you do is go config T or configure terminal, VLAN, which one calls it, the name of it, and end. So then here we have configure terminal VLAN 20, and we're going to call it student. Here's how you assign a port to the VLAN. You go configure terminal or config T, interface, and whatever interface is going out. Switch port mode access. Anytime you program a switch, you always use switch port mode and then switch port access VLAN, what the name of it is. So here it is, config T, interface F018, switch port mode access, and that port I'm going to put it on VLAN 20, and then end to put you back to the original prompt. If you remove something, all I have to say here is anytime you want to remove any command on a router or switch, just put no in front of it, and it will reverse what you did originally. Verification. Show interface, whatever port, switch port, and it will tell you exactly what VLAN it's on. So if you think you messed up, you can check the port to see what is happening. You can reassign the ports, or you can actually see the ports if you do a show VLAN brief, and you can see now we have port 11 on VLAN 20, and if you notice, it is gone from up here. Deleting a VLAN is the same thing that you would do normally. You can either come in and say delete flash VLAN dat, or you can say delete VLAN dat. This is typically combined with erase startup a delete VLAN dat, then reload on a switch. This way you will remove the actual RAM part, or the startup config, or the running config, and the VLAN dat file. These are just some brief commands you can do. You can do a brief, or you can do a command line that shows the summary, the name of it, whatever you need. Also be aware that you can also show the interface of VLANs, so you can say show VLAN, or show interface VLAN 20, and it will show you who's on that port, traffic map, broadcast, traffic, whatever. Here's how you do trunking now. You can go config T or config terminal interface, whatever you're programming. In this case, it's fastings there. Trunking, you're gonna combine two lines together to make one. Trunking VLAN 99 and allow the VLAN of your choice port to go through. This is an example of it. Faculty staff is 172.17.10.024. These are the other ones. All of these three will be converted to a trunk, and it will go through this trunk here. Resetting it would be a configure T interface support, and remember what I mentioned before. You always put the no command in front of any command that you have inputted or you think you may have messed up on. So that's why I wanted to bring that back up to you again. Here, interface, no shutdown, no switch port, trunking, no nothing. Whatever command you want, you always use to know. And then after you do the command, it should show you that it is down. Verifying trunking, you can just do, after you make your changes, you can say show interface fasties in the 01, and it will show you what's happening after you've done the change. IP address issues. You need to be very careful because you can have various VLANs, but you need to make sure that you do not overlap IPs, or you make sure you put in the correct IP of where you're going per VLAN per machine. If you have a missing VLAN, this is just a little graphic that you can see that, you know, need to connect, need to create, need to delete, need to verify. So this is why I like I mentioned before in class, you always have to do is show command to make sure what you've done actually exists. Missing VLANs, show MAC address table interface, whatever, fastest in a gigabit, and it will show you that VLAN 10 is on here and VLAN 10, and it will say it's inactive because you have an overlapping MAC address situation there. Introducing troubleshooting and trunking. If you look at this, all you have to do is say show interface F01 trunk, and it will show you what mode it's in, automatic, encapsulation, 802.1q or .q, and trunking, and which ones are connected to it. Problem with trunking issues are usually associated with incorrect configuration. Make sure that all your IP addresses, subnets, a direct connection, direct links are correct. Because if a trunking has a problem, it's going to really affect the overall performance of your router and switch. Here's some other ones that you can have. You can have a native VLAN mismatch, a native mode mismatch, also VLANs on the trunk. Here are the results and examples of how that would happen when you're programming your router switch. Here's another example. Incorrect ports. Make sure when you're programming ports, and you have learned this from the live labs, is document where you plug stuff into. This, I have to say, this is the most crucial thing that you need to remember. Document, document, document. Okay, this right here is just an incorrect VLAN list. You have a VLAN here that has nothing on it, nothing on it. So you need to make sure that when you program a VLAN that you do put what needs to be on it there. Otherwise, it's just a waste of time, waste of resources, and most of all, waste of money. Incorrect VLAN list must be allowed on trunk before the frame can be sent. All this wording here basically means is make sure that the connections you want are the connections that are there, and they are active, and that they have a protocol that allows for forwarding. Otherwise, you will not be able to run your VLAN correctly, and you will get calls saying, I cannot connect to the internet, I cannot connect to the intranet, and so forth. Inter-VLAN routing is basically just taking the information you have, VLAN 10, VLAN 20, and allowing them to connect together. Large networks with a large number of VLANs require many router interfaces. Like I mentioned before, if you have a lot of VLANs, you need to actually segment them by either giving them more broadcasts or switching areas from the VLAN itself. Here's an example. You can have trunk. So all the information on here are going through these trunks. And then up here you have the multiple pathways from your network to the internet out to the world. Router on a stick is only used on one physical router interface at present, which means every time you program a default gateway, like say at your home, you only have to put in one physical IP address now or default gateway. And if it's only one, you do not have to put that in there. What the default gateway basically means is I have multiple routers going out. Which one do I want to go out on? Router on a stick. This is an example. We have one router going out, and this is the stick. And trust me, I do not make these terms up. Router on a stick is a legitimate phrase that is used in computer networking. So just be aware of that. Here's a legacy router on a stick where you have one router, switch, and network. So all of these guys here, you program their IP addresses, subnet mask, but you can, if you want, put in the default gateway, but because there's only one way out, it is not needed. This is another router on a stick where we have multiple combination of connections coming through. In this case, you can put primary, backup, or whatever you wish to do to create the connection to the internet. Here's another legacy one you can do. Legacy Inter-VLAN routing requires routers to have multiple. So this is the case. You lose one, you get another, or vice versa. And you can, if you don't put a default gateway, it will pick whichever one's available at the given time. And here is how you program it. Interface gigabit 00. There's your number, no shutdown. So all you're basically saying is one of these two will work to get out of where you're at. Here's another screen of what is mentioned. This is just another alternative to legacy interface. This is where you can actually come in and tell it to do multiple outputs through the same thing. So here we're doing sub-interfaces, which means we're taking one interface, G001, and we're combining what are called sub-interfaces, which means these three interfaces represent the three networks connected, but they are all going out to 0 interface. So 0.10, 0.20, 0.30 are the VLANs, but they're using the same connection. Configuring router on a stick is basically VLAN, the interface you want to put it on, and switch per mode trunk, which means it's going to trunk the information from these two VLANs through the connection. In the program it, you're going to do interface in the port, but in this case we're doing a sub-interface. It's going to be gigabit 00.1. This is your sub-interface within the existing 0.0 interface. You're going to do an encapsulation, address, port, encapsulation, address. And then if you show VLAN, you'll see that it is trunked, and it will tell you that this one port will accommodate 10, this one port will accommodate 30. And if you want to verify, just do a show IP route, and down here will show you the sub-interfaces and what's happening. And remember, the L is local, the C is connected. So L is what you're currently connected to locally, like from your machine, router 2, and connected is who are you connected to on the other end of your connection. You can do ping commands and trace routes. Remember, ping commands just verify that the connection is there. Trace route will actually check to see if you can transmit information from point A to point B. Okay, we've explained what VLANs are on a switch network, how to program them, what they do, troubleshoot them, and describe the layers of the internet VLAN routing. It's also what to do with old equipment and also router on a stick. Remember, router on a stick, all that means is you have one router going out to the internet or out of your network, and therefore you do not have to put a default gateway on. If you have more than one router accessing the World Wide Web, internet, you need to put in where you are going, so you make sure that this particular VLAN is secure or this particular network is secure going out to that particular VLAN, or I'm sorry, to the internet. I'd like to thank you very much. This is chapter 6.